Okay, let's take a look at this problem. The musician group is comprised of 6 violinists, 3 violists, and 2 cellists. And we want to know how many ways can we select 2 violinists, 1 violist, and 1 cellist. And the second part of the problem is how many ways can we select a first and second violinist, and a violist, and a cellist. So let's think of the first part of the problem. We think of it as performing 3 tasks. Task 1, choose a violinist. Task 2, choose a violist. Task 3, choose a cellist. So task 1, select 2 violinists. Task 2 is select a violist and task 3 is select a cellist. Then, in order to have a total of 2 violinists, 1 violist, and 1 cellist, we have to perform task T1, then T2, then T3. And the total number of ways of doing that is the number of ways that we can perform task T1 times the number of ways that we can perform task T2 times the number of ways that we can perform task T3. That's the fundamental counting principle. So here we're selecting 2 violinists, and the order doesn't matter. So the number of ways that we can do that, we just can represent it by this. The number of ways to select 1 violist from 3 violists, that would just be denoted by this. And finally, to select cellist, again, just to keep it the same notation, that would be this, and this number times this number times this number. That then would be the number of ways that we can make our selection. So let's see what this comes out to be. Here we have, here, 6 factorial divided by 6 minus 2 is 4. So that's 4 factorial times 2 factorial. And here we have 3 factorial divided by 3 minus 1 is 2 times 1 factorial. And then here, 2 factorial divided by 1 factorial and 1 factorial. It's pretty obvious what this one has to be, but let's just keep the same notation and the same logic all the way across here, same approach. So let's see, this is 6 factorial, so this is equal to 6 times 5 times 4 factorial divided by 4 factorial. 2 factorial, that's just 2, times 3 factorial, that's the same thing as 3 times 2 factorial, divided by 2 factorial. 1 factorial is just 1, and then here, that's 1, that's 2. So here we are. Let's see, it looks like this, and this will cancel. These will cancel out. That's 3, so this is going to be 15 times 6 equals 90. So to select the 2 violinists, to select a violist, to select a cellist, that can be done in a total of 90 different ways. Again, just using our basic combination approach and the fundamental counting principle. Now let's take a look at the second part of the problem. Here we have to select a first violinist and second violinist. So we're still selecting two violinists from among the six. Let's just erase this. That's 90 to answer that question. Let's focus on this one. Six violinists. How many ways can we select a first and second violinist and select a violist and select a cellist? So here we're still selecting two violinists, but before it didn't matter which order we selected them in. Now it does matter because we're distinguishing between the first violinist and who's going to be the second violinist. So here we still have two separate tasks. Task T1, choose first and second violinist. Task T2, choose a violist. And task T3, choose the cellist. Now here, this is not a combination problem. Now this is a permutation problem, because in this case now, the order matters. So the number of ways that we can perform this, that is choose a first violinist and a second violinist amongst the six, that is this permutation. We have six violinists, we're going to choose two of them, the order matters. Here, this is the same as before then. We have three violists, we're going to choose one of them, the order doesn't matter. And same thing for this. We have two cellists, we're going to choose one of them, the order doesn't matter. And now to perform task T1, T2, then T3, the total number of ways that we can do that is this, times this, times this. Now this, you remember, is equal to 6 factorial divided by 6 minus 2 is 4 factorial times C1, this is 3 factorial, 3 minus 1 is 2 factorial times 1 factorial. And again, let's just keep everything formal. Here we have 2 factorial divided by 1 factorial times 1 factorial. So here this will be equal to 6 factorial, that's 6 times 5 times 4 factorial divided by 4 factorial. This is 6 factorial right here. And here we're going to have these cancel. This is just 1. 3 factorial, that's 6. So we have this. Those cancel. 6 times 5 is 30, times 6 equals 180. So there's 180 ways then that we can choose a first and second violinist, choose a violist, and choose a cellist. So this problem, or this part of the problem, we should say, involves combinations and a permutation. The reason again for the permutation is here now the order in which we select the two violinists matters because we're selecting the first and second violinist. Okay, that's it for this problem. Come back and join us in the next video. We're going to consider some more combination problems. We want to relate them back to when we were dealing with permutations that had repeats. Remember that if we have n objects, but not all of them are distinct, the number of ways that they can be permutated is this. we're going to work some more problems like this, but we're also going to show how in many instances you can use the combination approach to solve these types of problems as well. And that's what we're going to continue doing in the next video. So come back and join us for that. We'll continue to solve some more problems.